class, welcome to lesson 8.2, which is all about using the distributive property. So by the end of this lesson, you should be able to use the distributive property to factor polynomials. So we're combining previous knowledge about the distributive property along with factoring, okay? And by the end of this lesson, you should also be able to solve equations in the form of ax squared plus bx equals 0, okay? So we're going to learn a couple new things today. So first, let's practice using the distributive property to factor each polynomial. So this is where you look at this first problem. You see I have 15w minus 3v. So what you can do, you can say 3 times 5 times w is my 15. I have negative 1 times 3 times v is my second one. And then you can see that, hey, I have a 3 in each one. So I'm going to pull that 3 out. In distributive property, remember, we always use parentheses. So if I divide everything by 3, I'm left with just 5w. And for the second one, I'm left with negative 1 times v. So that's the same as minus v. And that would be my answer. Okay? Then if we look at the second one, I have 7 times u times t times t. I have 3 times 7 times u times t. And I have negative 1 times u times t. So if I look, I have a u in each one, and I also have a t in each one. So if I pull out a u and a t, what am I left with in the first one? I have 7ut plus 21t, because I can remultiply my 3 times 7, and then minus 1. Don't forget that negative 1. So that's one way to solve it. If you don't want to write all of this out, there's a shortcut method where you can look and see, okay, if I'm pulling, I see they all have a u and a t in common. So if I just take one of those away, if you can look and say, I'm taking a u out of here, so this is going to go down to 1. I'm taking a t out, so this is going to go down to 1. This u is going to go away, and this is going to go to 1. And I'm taking ut out, so this becomes just 1. If you want to go through and cross things off like that, that's fine. But make sure this is the answer you end up at. Go ahead and try to use the distributive property on your own and see how you do. Hopefully you ended up with 3xy times the quantity of x plus 4y. If you have any questions about that, be sure to ask for some help. But why don't you try one more problem before we move on. Hopefully for this next one you had 3ab squared times the quantity of 1 plus 5a plus 9b. If you have any questions about that, please don't hesitate to ask. We're going to jump forward into the next concept. So this is something that you maybe want to take a screenshot of or write down in your notebook, specifically this bottom part. I think the word portion, while it's good for you to read, it's something that you guys tend to get confused while reading it, and you tend to like the symbols better. So bare minimum, write down whichever one works best for you. For a lot of you, I know that's the symbols. So we have ax plus bx plus ay plus by. Okay, so a and b are going to be different numbers. What you want to do is you want to group them together. So we're going to add some parentheses in, like you see in this first one right here, because we're adding everything together anyways. So adding in those parentheses doesn't change anything. But then what we can do is ax plus bx, we can factor out that x, and ay plus by, we can factor out that y. And when we do that, the next step is going to be to write it as a sum, or not a sum, a product of two sums. So then you pulled out an x and a y, both positive. So you're going to put x plus y together, and then you have a plus b in one parentheses and a plus b in the other. So that's what your next set of parentheses is going to be. If that doesn't make sense, don't freak out yet. We are going to do some examples, okay? So first, we want to group things together. So if we look at our first one, I see I have an Rn plus 5n minus r minus 5. So I see I have an r term here and an r term here. So I'm going to rewrite it, Rn minus r plus 5n minus 5. So I grouped them together based on the r variable. And then if I look at this step, I want to factor something out of each set of parentheses. So in the first set, they both have an r. So if I do r and pull that out, I'm left with n minus 1 plus, in the second set of parentheses, they have a 5 in common. So I can say plus 5, and then in parentheses, if I divide 5n by 5, 5n divided by 5, my 5's cancel, I'm left with n, and negative 5 divided by 5 leaves me with a negative 1. When you do this step, one important way to know if you're doing it correctly is if you end up with the same thing inside your parentheses. If you end up with the same thing inside your parentheses, you're doing it correct. If you end up with something different in your parentheses, you probably have an error somewhere. So then your next step is to take the terms outside of your parentheses. So r plus 5 is going to be one of your parentheses, and you're going to do a product, so you're going to multiply, and then you take your inside the parentheses stuff that you had left. And this is going to be your final answer. You might wonder how that works, but if I use FOIL, my first terms give me Rn. My outer terms are r times the negative 1, so it's a negative r. My inner terms is 5 times n, or 5n. And my last term is minus 5. So if I rewrite it, that ends up being the same thing that I originally had. Okay? So you don't have to do this purple step. This is just a way to check. Our next problem, we have 3np plus 15p minus 4n minus 20. Okay, so one way I can group these is actually I can leave it the same way because I have p in both, and also I see 3 and 15. I know those numbers work nicely together. So I'm going to say that I have 3np plus 15p plus, and then I have negative 4n minus 20. If I look at this first parentheses, I know I can take a 3 and a p out of each one. So I'm left with n plus 5. And then I have plus, what do negative 4n and negative 20 have in common? They can both be divided by a negative 4. So negative 4n divided by negative 4 gives me n. Negative 20 divided by negative 4 gives me a positive 5. So I look, my parentheses have the same thing, so they check out. So then I write my product using the outer term. So I have 3p, and then I pulled out a negative 4, so that turns into minus 4. And then I have the inside of my parentheses, so n plus 5. And if I FOIL that, I end up back at the same answer. Okay? Go ahead and try one on your own. Hopefully you ended up with 4x plus 3 times y minus 5. If you have questions, be sure to ask for some help. Let's look at example 3. We want to factor by grouping with additive inverses. Okay, so this is the same idea still, but it's going to look a little bit different. So we have c minus 2d, if I group those together, and then I can group my 8d minus 4. My first set, they have a c in common, so that becomes a 1 minus 2d, plus I can pull out a negative 4. So that leaves me with negative 2d plus 1. And if I look, My order has changed. I have a negative 2d and a negative 2d, but I also have a positive 1 and a positive 1. So I know I'm still okay. I can do c minus 4 times 1 minus 2d, or I like to write it with the variable first. So I'm going to switch it to negative 2d plus 1. Maybe when you did the step before, you might have pulled out a positive 4. And if that's the case, you would have had c 1 minus 2d plus, and then 4, you would have ended up with 2d minus 1. So one thing with that is if you look, you have a positive 1, a negative 1, but a negative 2d and a positive 2d. When that happens, that means one of the items that you pull out, whether it was the c or the 4, you need to switch that to a negative, so like what we did. So that way it switches the sign inside the parentheses, okay? So if you end up with something where they are called additive inverses, where it's the same numbers but opposite signs from each other, you just have to pull out a negative something. So let's start by grouping. If I look, I have a p variable in common here, and then also for my 18 and 27, I know those have common factors of 9. So if I keep going, I can pull out a p on the first one. So I'm left with 3 minus 2p, and then plus, there should be a plus symbol in there when I got rid of plus, if I pull out a 9, I'm left with negative 2p plus 3. So if I look, I have negative 2p, that's okay. I have 3, that's all good. So I know I'm going to write p plus 9 times 3 minus 2p, or since I prefer to put the variable first, I'm going to switch it to negative 2p plus 3. And that would be my answer. Again, if you would have pulled out a negative 9, you would have had the opposite, and you would have known you have to switch the sign of something. Go ahead and try factoring this one on your own. Hopefully you ended up with negative 2x plus 3 times y plus 5. If you have questions, be sure to ask. All right, zero product property. Basically what this says, if I do 3 times 0, that's going to equal 0. If I have 3x times, let's say there's a 4 in there. If I put a 0 in here, that's going to equal 0. Because 3 times that, or a number times 0 is always going to be 0. Okay, so we want to focus on how to get to the number 0. So if we look at letter A, we have 3n times n minus 2 equals 0. I want to know what I can plug in for n in order to get to 0. So if this is one number and this is a second number, we need one of our numbers to be 0 because we're multiplying. So if we turn this to 0 and we left this, that's going to equal 0, right? So I want to know, how do I make 3n equals 0? Well, 0 times the number gives you 0. So we know n has to equal 0. Then the other way is if we kept the 3n but changed this to 0, 3n times 0 will give us 0. So we want to know n minus 2, when does n minus 2 equal 0? Well, if I tee it up and I add 2 to both sides, I have n equals 2. Okay, so the way you solve these is basically what I just did, but I'm going to break it up a little bit more. If you can see that there are 2 separate things here, and you set them both equal to 0, like this, you break it up into 3n equals 0. You can find out what n equals in that situation. And if we have n minus 2 equals 0, n equals 2. doesn't matter which one of these two numbers you use, you'll end up at 0. So let's try our next one. First, we need to set it up in that same way with the factored form. So I look, what do these have in common? They both have an 8 and a b, and I'm left with b minus 5 equals 0. So I'm going to take 8b, I'm going to set that equal to 0. I'm going to take b minus 5, set that equal to 0. So for 8b, b has to equal 0 in order to get back to 0. And for b minus 5 equals 0, b has to equal 5 to get back to 0. So that's how you'd solve that one. Letter C, we need to get everything on one side and set it equal to 0. So what I'm going to do, I'll tee it up. I'll add 10x. I'm left with x squared plus 10x equals 0. So if I go from there, I need to factor. I know that x goes into both of those. So I'm left with x plus 10 inside parentheses. And so I say x equals 0. Okay, that one's done. And then I have x plus 10 equals 0, or x equals, if I tee it up, subtract 10 from both sides, I have x equals negative 10. All right, go ahead and try to solve this one on your own. Hopefully you decided that s had to equal 3 or negative 2. If you're a little confused about that, set it equal to 0. So s equals 3, or we have 3s plus 6 equals 0. If you tee it up, subtract 6. Divide by 3, you end up back at that negative 2. Try another one on your own. Hopefully you ended up with 0 and 1/8. If you have questions about those, please be sure to ask for some help. All right, let's look at example 5, which is our word problem for this section. So we're talking about a kangaroo, okay? So the hop of a kangaroo can be modeled by the equation h equals 24t minus 16t squared, where h represents the height of the hop in meters and t is the time in seconds. Find the values of t when h equals 0. So we want to take that 0 and we want to plug it in right there. So we have 0 equals 24t minus 16t squared. We're going to do that same process where we factor out numbers first. So 24 and 16, h goes into both of those, and we also have a t in common. So 24t divided by 8t gives me 3 minus 2t. So that means I have 8t equals 0, and I have 3 minus 2t equals 0. So I know this one turns into t equals 0. So before the kangaroo hops, its height is 0. So that makes sense. And then the last one, if we subtract 3, we have negative 2t equals negative 3. Divide by negative 2. We are left with t equals 3 halves, or t equals 1.5 seconds. So after 1.5 seconds, that kangaroo has already jumped and landed. Okay? So that is what that question is asking. Go ahead and try this question about jumping on a trampoline. Hopefully you ended up with at 0 or 1.5 seconds. If you have questions at all on 8.2, please be sure to ask either myself or a friend for some help. Have a great day.